In this lesson, we're going to look at the big ideas behind hypothesis testing. So, what is a hypothesis test, or it's also called a significance test? Well, it's this formal procedure for using your observed data to decide between two competing claims. So observed data means you're looking at your sample to decide which of two competing statements are true. You begin by writing these two hypotheses. These claims are statements about your population parameter. So let's talk for a second about these two hypotheses, the null hypothesis versus the alternative hypothesis, which is written as H sub 0, also called H naught, and H sub A indicates the alternative hypothesis. Your null is the situation that's assumed to be correct in a scenario unless you have evidence that will then suggest otherwise. Your alternative is your situation for which your evidence is being collected. Or sometimes you can think of it as like whatever maybe your researcher is truly hoping to find is your alternative. Your null is like your no difference. It's a status quo. It's what's always been true in a scenario. So the null is always a statement of equality. Most times in the AP world we write H sub 0 equals something. But I want to point out that it's also correct to say that it's greater than or equal or less than or equal to. It's just typically not written this way, though it's assumed to be that way. The alternative is always a statement then of inequality, like H sub A, something is less than, or something is greater than, or even not equal. And if it's not equal, this is where we have what's called a two-sided test. These would be one-sided. It's easiest to, of course, understand the null and alternative by looking at some specific examples. So in class we talked where I said, you know what, I'm an 80% free throw shooter. I make 80% of the baskets and I never lie, right? So this would be my proportion. Notice I'm using P and not P hat is equal to 0.80. So the alternative is, you know what, you guys thought that I wasn't really that good. So P would be less than 0.8. Okay, so then you're going to run your significance test assuming that the null is true. Second example, we field test a new flavor of soft drink. We are planning to market the beverage only if we are sure that over 60% of people like the flavor. So our null. First of all, this would be that the population parameter is equal to 0.6. It's always a statement of equality. The alternative would be that your population parameter, P, is equal to, not equal to, excuse me, is, if only we're sure that over, so greater than 0.6. Now, just to mention how I said sometimes your null can be written another way, it's kind of understood that the null could also be that P is less than or equal to 0.60, okay? Because if you think of a number line, it's either got to be greater than, equal to, or what about the less than or equal to? So really the null is this. It's just I am not going to be writing it this way in this course. You will see it that way and it is acceptable. Okay, next example. 20% of cars of a certain model have needed costly transmission work after being driven between 50 and 100,000 miles. The manufacturer hopes that a redesign of a transmission component has solved this problem. So the null would be that 20% of the cars need transmission work, okay? But now they're hoping that they've solved this problem, meaning they're hoping it got better or that fewer than 20% of the cars need costly transmission work. So there's your null, and then what they're hoping for, that alternative. The null in this one, in the 1950s, only about 40% of high school graduates went to college. So again, this is a proportion. So P is equal to 0.4. Now, I've focused on proportion examples here in this video, but if it were talking about mean, just make sure you use mu. Never ever use X bar or P hat when talking about your hypotheses. All right, has this percent changed? Well, has it changed? That means it could be less than, it could be greater than. We don't write this as two separate. We just say P does not equal 0.40. So the big idea of inference here, okay, I claimed that I was an 80% free throw shooter, okay? You all suspected that I was lying, that I was really less than 0.8, so we called that the alternative. So what I do is I build a sampling distribution where P is set at 0.8. I'm going to calculate then what's the probability of an observed sample, and I had an observed sample of something like 0.62, and I want to see how rare is that, okay? So we find the probability of that occurring. If that probability is low enough, well, our conclusion is, you know what, that's so rare, that's not going to happen by chance. We're going to reject our null hypothesis and say we have convincing evidence for the alternative. But if it's not rare enough, then we have no choice but to fail to reject our null hypothesis. So how rare is rare enough? Well, that leads me to talk about my significance level. Like, you want it to be rare. Often we say 5% is pretty rare. If it's less than or equal to 5%, pretty good. Sometimes we even get more rare than that. We say in medical studies, maybe we want it to be less than 1% to be convinced that we can have convincing evidence for the alternative. So that leads me to our vocabulary. Words. We're going to look at the p-value and our alpha level. Okay, so your p-value, that's the probability that's computed by assuming that your null is true, that the observed statistic, whether it be p hat or x bar, would take a value that's as extreme or more extreme than the one actually observed. And of course, the direction specified by the alternative. Your significance level, alpha, is that predetermined probability of rejecting the null given that it is true. All right, so here's the big idea as well. If the p-value is low, we're going to reject the H sub O. If your p-value is less than or equal to A, you reject the null and state you have convincing evidence for your alternative. Where if the p-value is larger than your significance level, you're going to fail to reject the null. Please never state that you're accepting the null. Please say that you fail to reject the null. We do not have convincing evidence for the alternative in context. So let's look at a scenario here and identify our null and then observe what our conclusions would be based on our p-value. So a company has developed a new deluxe AAA battery that is supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company would like to be convinced that they really do last longer. Based on years of experience, the company knows that its regular AAA batteries last for 30 hours of continuous use on average. On average is signaling to me that we've got a question about means. The company selects an SRS of 15 new batteries and uses them continuously until they are completely drained. The sample mean lifetime is 33.9 hours. A significance test is performed using the following hypotheses. Okay, so we've got to develop it. First of all, when they mention that sample mean, that's nothing to do with your null hypothesis. Okay, you're going to write your null about your population. Okay, so since it's mean, I'm going to use mu, not x bar. So mu is equal to 30. And my alternative is they're supposed to last longer, so mu is greater than 30. Now, just as you're doing this problem, do you have any evidence to even suggest that maybe they've gotten better? Well, yeah, we have some evidence. We're told 33.9 hours is what the sample mean. Okay, so we've got some evidence, but we're going to test, is that evidence enough to convince us overall? Is it rare enough to suggest that our population mean is shifted to greater than 30? Okay. So just kind of rereading that statement because we filled it in. A significance test is performed using the following hypotheses where the null is mu is equal to 30 And the alternative is mu is greater than 30, where now I state what mu is, where mu is, I'm describing the parameter, the true mean lifetime of the new deluxe AAA batteries. The resulting p-value, so after they run the whole test, which we'll talk about how we do that, is 0.0729. What conclusion would you make for each of the following significance levels and justify your answer? Okay, so if alpha, and I know that looks like A, I want it to be the Greek letter alpha. If alpha was equal to 0.10 or 10%, what would our conclusion be? So for part A, because the p-value, which equals 0.0729, is less than alpha equals 0.10, we reject the null hypothesis, okay? So when the p-value is low, you're going to reject the H sub O. Now we're going to put a statement in context. We have convincing evidence that the company's deluxe AAA batteries last longer than an average of 30 hours. So what did I do? I rejected the null. I compared the p-value to alpha. Because it was low, I rejected the H sub O. Then I stated that we have convincing evidence for the alternative in context. So how does that change for part B? So what I'm going to state now is because the p-value equals 0.0729 is greater than my alpha equals 0.05, we fail to reject the null hypothesis. Never, ever say that you accept the null hypothesis. We do not have convincing evidence that the company's deluxe AAA batteries last longer than 30 hours on average. We never, ever accept the null hypothesis. That would be like the jury in a criminal trial declaring the defendant innocent when what they really mean is not guilty.